Hi, in this video I'm going to be giving you an overview of using the Beamline controls and data acquisition computers for the X-ray Microprobe Beamline at GSECARS. I'll also show you how to use RealVNC to access these Beamline computers for remote access. Hi, I'm Matt Newville, one of the Beamline scientists at the GSECARS Microprobe station. If you are going to be running remotely, you should have already received an invitation from one of us at GSECARS to connect to the CARS computers with RealVNC. You should have downloaded the application and be able to see that you can launch that application and see that you can connect to the CARS computers named Ferrari and Alpina. We use Alpina mostly for data visualization and analysis. You're welcome to use that, but in this video and in all the videos in this series, I'll only be showing you connecting to Ferrari. From Ferrari, you can do all of the data collection and all of the data visualization as well. And we find it generally easier to use one machine at a time remotely. If there are multiple people in your group and someone wants to be doing the visualizations or analysis with Alpina, that's completely fine. But in this video, I'll only be showing you how to do data collection with Ferrari. When you first launch RealVNC and connect to Ferrari, you'll notice that it's a machine with 4 monitors arranged in a 2x2 square. Actually, first of all, I should say that you may actually get a login screen first. We've sent you the username and password in an email to connect to it, and you can use that to log in. When you log in, you'll see this 4x4, 2x2 screen of 4 monitors. RealVNC has a Properties tab that comes down. If you scroll in the center part of it, up at the top center, a little menu comes up, and you can use this to change the aspect ratios and so on. You can also have it send Control-Alt-Delete. So if you're on a Windows machine and you want to send Control-Alt-Delete to Ferrari, you can use that button to do it instead of using your keyboard, which would send Control-Alt-Delete to your keyboard, to your computer. But from this, there's also a gear icon for properties, and I'm going to click on that now. And here, there's some general settings that are mostly just information, but under the options, you can change the scaling so that you can see a bigger window so that you can read the fonts and be able to read the text on these screens. So right now, it's a scale to fit, but I'm going to select 75%, which we generally find is a good compromise for most people to be able to see enough of the screen at a time and also be able to read the fonts on the screen. So I'll select 75% and click OK, and then that resizes the window. I'm going to drag it around so it comes in here. So now we have a single view of one window, basically one window at a time, and there are scroll bars to move around on top and on the right and on the bottom. I should also say that in that menu bar that still can come down, there's also a view only mode. And if you click that then and select OK, then you won't have control of the mouse on Ferrari. With multiple people connected, there's always competition for the mouse. Who has the mouse, and just accidentally moving around can move the mouse out of boxes, and so be frustrating for other people who are trying to drive the data acquisition. So if your intention is to only watch the data come in, it's a good idea to go into view only mode. I will say that Tony and I will generally go into view only mode once we feel like you guys are ready to run, and we will just watch you run and switch back to not view only when we think we should be taking control. So I'm going to not select that now because I'm going to want to show you what the controls are. First, in the upper left window, you see a camera view of the station and your samples. Here we have let me zoom out more completely for those of you who have not been at the Beamline or forget. The beam comes from the right, so there's high vacuum from up to this port here with a beryllium window, then a vacuum, and then a helium flight path all along here to your sample. Actually, there are helium flight path, and in that helium flight path here are a set of slits that we keep set to about 300 microns square or so. That changes some. A set of filters and a shutter that we can drop into the beam, piece of lead that we drop into the beam to prevent the X-rays from hitting your sample. An ion chamber for measuring the incident flux, and then mirrors to deflect and focus the beam from the 300 microns or so down to the 1 to 2 micron spot size on your sample. If I zoom in on the mirrors there, you can see that those are a flat piece of silicon, about 200 millimeters or a little bit longer long, and that's pitched at somewhere between 3 and 5 milliradians, depending on the day and the kinds of x-rays we want to get onto your sample. You can see that there's a metal coating that's rhodium on top of the bare silicon. And then although it's a flat piece of silicon, we bend it into an ellipse by pushing down on these bars on the top. The X-ray beam goes through this little slot here. We push down on those bars to try to make an ellipse. The X-ray beam goes through that, and as the ellipse focuses the beam from the spot that is the source 50 meters upstream to your sample. And then there's another mirror that focuses in the vertical here. From this medium zoom, you can see that our sample holder, a typical sample holder for us, will hold 6 samples at a time or so, depending on what your samples are, and maybe we'll tape some other things on top of that. Here we have the beam coming from the right, and would go straight through. Here's an ion chamber in the back for measuring transmitted intensity if we're measuring XF standards or foils for energy calibration. There's a tube here that is the microscope for viewing your sample. It views the sample at normal incidence. The sample sits at 45 degrees to the X-ray beam, and then at 90 degrees to the X-ray beam is this fluorescence detector, which is the workhorse of doing the work for the X-ray microprobe station. I'm going to zoom out once more. There again, you can see that's the line of the beam. Actually, this square rectangular pipe in the back is the vacuum pipe for the other branch of our canted undulator beamline. So that is also like the direction of the beam. That's what the other groups are using. And the beam goes along here. 90 degrees is where the fluorescence detector is, and your sample sits at 45 degrees. We'll normally leave this view zoomed in, but you're welcome to drive around, and if that helps you navigate your samples, then you can certainly use those windows to drive around. Going around the other screens, I'll show you in more detail later. Here's the X-ray. Here's the microscope view, a 1 millimeter field of view, and we can control where the sample is in the beam with this application. I'll go over this in more detail in later, the next video. Over here on the bottom right, we typically leave the EPIX scan application for acquiring X-ray fluorescence maps, and XF scans, and for doing macros of large acquisitions. So that will do all of the scanning. In the upper right, we typically keep the X-ray fluorescence energy dispersive spectra going. So here's our X-ray fluorescence spectra from the sample we're on, the metal holder of the foil. And I'll go over this in more detail in a later video. We also have a EPIX instruments control application so that we can drive around sample stages and detector stages. I'll show you that in more detail in a later video. But first, to wrap up this video, I'm going to show you this screen here, the 13 IDE Microprobe screen. This is an interface to our low-level EPIX data acquisition system. We don't expect you to actually drive these screens much at all. These are mostly for information purposes, but I'm going to show you what information you may want to look at from these screens. First of all, there's the ring current at the top, reading 86 milliamps. If that's 0, then the beam has been lost, and there will be no X-rays in your station. There's a shutter. This is the main shutter for the station so that we can open the door. You won't need to use that if you're in remote mode, but if you're at the beamline and you want to go into the station, you can click that close button to close the shutter and then be able to open the door to go in. This also shows the APS permit, so whether we're allowed to have beam, and that might be if there's a beam dump or if something has gone wrong, we may not be allowed to have beam. And then there's also our own Beamline Equipment Protection System, or EPS. And these lights are all green. That's good. If one of those lights is red, then that probably indicates a problem with our beamline that is preventing you from getting X-rays. Here we also have, down below, we have the energy of the monochromator, currently around 20 keV, and some information about the undulator settings that you shouldn't need to worry about. But then the next box down, we have the I0 flux, the flux hitting the sample as measured in that ion chamber between the slits and the mirrors, and that's reading in at 3 times 10 to the 11, which is a proper kind of flux for most acquisitions. The flux can vary between the 9s or 10 to the 9s or 10 to the 10s up to 10 to the 11, and occasionally higher than that, into the 12s for some settings. Down below, we have this red and blue trace, which look like the lines at this point, but they're measures of the intensity, going back, instantaneous measure of the intensity. And as we move the beam around, or if I move these piezoelectric crystals on the second crystal of the monochromator intentionally, then the beam can go away, or we can bring it back. You won't need to do this. We have scripts that do this frequently, and we'll be able to help you. But it's useful to be able to look at that and say that the blue curve is good and it's about 1 or 2, and that means that there's the right amount of beam. And the red curve is also on. The red curve is the intensity further upstream, and so is on even more often. In fact, we also have over here filters and shutters. So we have pieces of metal aluminum foil that we can drop in the beam. At 20 keV, they don't do much, but at 10 or even 7 keV, they can do a lot to attenuate the beam, which might be useful for controlling beam damage. And we also have a shutter, just a piece of lead on that filter that we can drop into the beam. And when I do that, the X-ray fluorescence spectra goes away. That intensity goes to 0, but the red line, the intensity upstream of the station, stays on. I open the shutter and the X-rays come back and illuminate your sample. So that's a good way to prevent the X-rays from hitting your sample or measuring dark currents and so on. We'll use that shutter for most of the time when we mean turn the beam off, but not go in the station. So that's the overview of the data acquisition and control computers. In a later video, I'll go in more detail over all of the other applications here and show you how to collect X-ray fluorescence maps and XF data on interesting points in your maps. So I hope that was useful and that you have a good experience at the X-ray Microprobe Beamline. Thank you.